Welcome back to the Command Center. Let's jump right into day 13 of our Security Operations Briefing. Today, we're tackling 3 massive data concepts that people constantly mix up: encoding, decoding, and hashing.
Seriously, are encoding, hashing, and encryption exactly the same thing? You'd be surprised how many seasoned tech pros use these words interchangeably. But listen, assuming they're all the same is a catastrophic mistake. Believing a formatted file is actually a secure file? Yeah, that's exactly how massive data breaches happen in the real world.
So here's our mission for today's explainer sprint. We're going to cover data encoding, decoding, the absolute powerhouse that is cryptographic hashing, and then pit hashing against encryption before wrapping it all up.
All right, Section 1, let's officially kick this operation off and clearly define the core problem we're looking at.
Our source material hits the nail on the head with this quote. It explicitly notes that while all of these techniques transform data, their end goals, which are formatting, integrity, and confidentiality, are completely different. Treating them like the same tool is literally like trying to turn a screw with a hammer. It just doesn't work.
Let's start with the formatter of the group, Section 2, diving right into data encoding.
Here is the absolute most important thing to remember. Encoding is not a security measure. It's just a translator. Its only job is to guarantee your data survives being transported. Think of it like taking unreadable binary code and turning it into a safe string of text so it can travel across a network without getting corrupted. There are no secret keys here, guys. It's totally an open book.
Take Base64, for example. Base64 encoding grabs complex binary data, chops it into smaller chunks, and maps it to a really standard 64-character alphabet. Why do we even do this? Well, so older systems, email protocols, or web APIs can actually read the data without crashing when they hit an unexpected special character.
We literally see this every single day with HTML and URL encoding. It's all about context. HTML encoding swaps out characters so text doesn't accidentally run as malicious code, like turning an ampersand into its entity equivalent. URL encoding, on the flip side, safely packages special characters using % signs so web addresses don't break. Different context, but the exact same goal: safe transmission.
Okay, moving to Section 3. What goes up must come down, right? Let's look at decoding the formats.
Remember how I said encoding isn't meant to hide anything? Well, that means decoding is just executing those exact same translation steps in reverse. It's all about recovering the original info so your application can actually use it.
The flow is super simple. 1, you receive the encoded string. 2, you apply the reverse translation map. And 3, you output the original data. The receiving system just takes that public rulebook, runs it backward, and restores communication. Again, no passwords, no encryption keys. Just straightforward, basic translation.
All right, Section 4, now we're escalating this briefing to an actual security measure. Let's talk about our verifier, hashing.
The absolute critical phrase you need to lock into your brain right now is one way. Unlike encoding, hashing is completely, mathematically irreversible. It acts as a permanent, totally unique digital fingerprint for your data. You cannot, and I repeat, cannot, reverse a hash to get your original file back.
When you feed plain text into a hash function, it spits out a fixed-length string of characters. And here's the genius part. If a hacker alters even a single tiny byte of a file, the resulting hash changes drastically. It immediately sets off alarm bells that the file was tampered with. This is exactly how we guarantee data integrity.
But wait, what if 2 users have the exact same terrible password, like 123456? Hackers know we do this, and they use massive pre-computed tables to crack them. Enter salting. By throwing in a randomized string, a salt, to a password right before we hash it, we guarantee that those 2 identical passwords will look completely different when they're stored in the database. It's a total lifesaver.
Section 5. Time for the ultimate cyber showdown. Let's finally clear up the biggest source of confusion in IT right now.
This is the absolute best way to remember the difference. Encryption is a padlock. You lock the data with a key, and if you have the right key, you can unlock it later. It's a two-way street. Hashing? That's a blender. You throw your data in, hit blend, and you can never, ever put that original piece of fruit back together.
It really all boils down to this matrix right here. Encoding, reversible, no key needed, used strictly for formatting. Encryption, reversible, requires a key, used for keeping things confidential. And hashing, never reversible, used purely for integrity. If you can memorize these distinctions, you're already way ahead of the curve.
Finally, Section 6. Let's debrief and see how these three processes actually team up out in the wild.
Every single time you log into a secure web app, all three of these technologies are firing off at the exact same time behind the scenes. Your browser encodes your session data so it travels safely, encryption shields your private info as it moves across the network, and hashing verifies your password on the server. They are the ultimate security team.
So, a quick checklist to wrap up day 13. Encoding changes the format. Decoding reverses that format. Hashing proves nobody messed with your data. Salting keeps those hashes unique. And encryption, that keeps your actual data a secret from prying eyes.
Awesome work in the command center today, but I want to leave you with one final provocative thought. As threat actors rapidly deploy advanced AI to manipulate files and impersonate users at scale, which of these three mechanisms is ultimately going to become our most critical line of defense for digital survival? Think on that for a bit. Stay secure, and I'll catch you in the next explainer.